Hey YouTube, I've spent the last 5 or 6 days porting my application to the NetBeans Platform, which is just a RCP platform that NetBeans creates and manages. The reason I was doing this is because NetBeans 7.1, the version I have, they discontinued support of the Swing application framework, which doesn't mean they discontinued support of Swing. As you can see, you can still design a GUI with Swing, but no more Swing application framework, which means that I had to port my app over to the NetBeans platform if I wanted to continue to be able to reuse any of my code. So I did that, and the way it works is they have these modules, and the program is made up of all the different modules, and it's supposed to be, this nice, great thing because modules only depend on each other if you explicitly state that they do, and it's very healthy, and there's no spaghetti code. Well, the reason there's no spaghetti code is because it's a pain to get your code to talk to code from another module. So you think, oh, yeah, it's going to be super clean because they have to jump through 400 hoops before one object can talk to an object in a different module. So I was having a lot of trouble, and I really didn't want to spend a month reading books on the NetBeans platform before I could continue developing my app. So I cheated. I put all of my code into one module. And the way NetBeans platform works is based off these. You see these top component classes? These are the windows. So window, see all these? Board, calculation, captured pieces, engine, history, notification, timer. All of these work, and NetBeans platform allows me to move this, let's say here. Boom, and now it's tabbed. Right? So NetBeans platform is actually really nice, at least the Windows system. And I can take full advantage of the Windows system without having to make my code all nice and modular. It's pretty modular. I mean, the only difference is I'm not using their idea of modules, which means I don't have to use their way of getting my code to talk to itself, to other parts of itself. So I've implemented some new things. Most of what I did was just... Okay, so one thing I did is with the board class, which is now the game board class because I have an engine board. But with the game board class, I really streamlined everything that happens from the moment the view sends a move to the controller to the moment the move has been made and everything is updated, so that functions like is it a checkmate now only get called once instead of 4 times, or functions like is it a castle queenside only get called once. The only function that gets called twice is team in check, because we have to check it for the team that's moving to know if the move is legal, and for the team that's not moving to know if they are now in check. So everything is as efficient as it can be as far as message flow in the game board class now, which is lovely. So then I created an engine package. Nice, all of these things. Castle and Noom, I actually don't use that, so let's delete, and we're still okay. Good, so we have an EngineMove, different kind of move. I know I should probably have an interface move that has a couple of accessor functions and then implement it differently with EngineMove or PGNMove, but I was really just wanting to get this done, and I didn't feel like I had time to be clean, and what difference is it really going to make? EngineMove, right? Okay. So what this class possesses is it's the most lightweight possible move that contains all of the data necessary for a board to make the move. So it doesn't contain anything that is not absolutely necessary to make it move. So we need to know if it's a castle queenside, because by the time make move is called, these flags have been accurately set, and by the time another position object far away somewhere in the tree is making this move, it can't know whether the conditions for castle queenside are met because it's a different position now, so this has to be stored, as does castle kingside. The promotion type has to be stored, and of course the origin and destination, and that's it. So this is the whole class. It's immutable, and it's just a data wrapper. Convert to regular move I have. And we also, that's for sending a move back to the view. And we also have, oh no, it's in the position. In the position class, we have a convert move to EngineMove, which works a lot like the refine move function of GameBoard class. So we have EngineMove. Let's go ahead and close out of everything. EngineMove, and we have position. Position is like board, or what GameBoard was. I mean, what board was and is now GameBoard. It has all of the move logic in it, and this is all it stores. Which turn? Two-dimensional array of slots and 4 booleans. So these are the objects that we're creating thousands and thousands of every time we build a tree. So trying to make them as lightweight as possible. And of course nothing is optimized yet. I just finally have it working. So now I'll go back and optimize. My goal with this position analyzer class, it has all of these functions that board used to have, but they're all static and you have to pass in a position. So the idea is that position will only be the data wrapper, and when we want to learn something about it, we run it through a function in the position analyzer class. I think it's cleaner. So create position from GameBoard. You pass in a GameBoard, the engine will probably be receiving a GameBoard object, and it creates a position object from it. So this code right here, I spent 3 hours yesterday figuring out what was wrong, because when I was creating all these new positions, and I'll show you in Trainus Engine, when we build a tree, Minimax function, we build a tree, and this function puts thousands and thousands of tree nodes in the tree. Each tree node contains a position object, among other things. And here was the problem. All of the position objects were pointing to the same array. Right? So I was just making new pointers to the same array. It was a new position object. It had all of its other members were separate, but I was looking in the debugger view, and they were all pointing to the same array. So I changed it. So I called array.clone, and then it still didn't work. So I thought that must not be the problem. What is it? I checked my code. I triple checked my code. I quadruple checked my code. And then I was looking even deeper into the array and realized that while they all had a different array object, every position in the tree was pointing to the same slot objects. So when I made a move and added it to the tree, the original position was also edited. Everything was being edited at once because I only had 16 slot objects for the 16 pieces instead of, the hundreds of thousands that I thought I had, because I wasn't actually copying them. So what we do is we created a copy board array function, which iterates through the array you pass in, creates a brand new array, new slot, allocating new memory. There's no ifs, ands, or buts about it. And we go through all of the objects in the parameter slot, and the result at that index is equal to slot.copySlot at the parameter index. And slot.copySlot is, of course, if I go to the slot object, it's of course very careful not. Actually, no, it doesn't. I don't think it has to worry, because coord is piece type you don't have to worry about because it's an enumerated type. But thankfully these aren't pointing when I do piece and type and coord. Like, I didn't have to run slot.type.copy. I didn't have to do that. Luckily, I didn't have to go all the way down. But this gives us a fresh, completely new array. So, create position from GameBoard. We get a completely new array, and then we just copy all the booleans and enumerated types from the GameBoard with no worries, because those are passed by value. Now Java is all pass by value, but the difference is when you pass in a pointer, you're not passing the value the pointer points to, you're passing in the value of the pointer itself. So really what you're passing around is an address in memory, not the object itself. When you pass primitives, you are actually passing the object itself. In this case, it's just a Boolean, true or false. So I had to do some reading about Java and pass by value and pass by reference and what all that meant. And I finally got here. Right, and I wrote some funny documentation in my frustration. Most challenging function I've ever had to write. I didn't leave the computer 6 hours. Make that 8 hours, and it still doesn't work. Make that 9 hours. It works. I had to read up on friggin' reference pointers in Java. I was passing the same slot objects to every single instance of position, resulting in all hell breaking loose. There were many other bugs, all fixed too. Woot. So there's some really nice, entertaining Java doc. What a minimax function does is you input a depth and a position to analyze, and it returns the move it recommends. That's a cool. It's a cool function. And I have a thing coming up in 5 minutes, so I'll make this quick. Basically, actually, you know what? I'll go over the minimax function in the next video. For now, we'll just do a demonstration. Are you ready? Watch the calculation window up here. Ah, it's building a tree. At depth 3, so all possible combinations of outcomes up to depth of 3, meaning opponent moves, it moves, the opponent moves, and it moves again, and then it recommends a move. Right now, it does not choose the correct branch in the tree. So that's a problem, but it does build a correct tree, which is more than half the battle, I think. Thanks for watching. I'll go over the minimax function in the next video.